Hey all, just a quick update. Finish up on, we were talking about CPE versus PTFE fuel lines. And I still had CPE tubing on my supply between the filter and the fuel rail. And of course, that started leaking now too. So and I remember in the last video, I'm pretty sure I said I was going to replace that. I just hadn't gotten to it yet, but I decided to take the car out for a run. And sure enough, I'm sitting here in the garage warming up, and I was looking into hooking up the tune, hooking up the computer to check the tune because I wanted to start running through the tune again with updated injector flow rates. And sure enough, I've got a fuel leak again at the same existing PTFE tubing. So I'm going to be replacing that. And I did have a couple. I had a question come in about the inner diameter of the PTFE tubing in 6AN, and I just wanted to show. So this is my PTFE tubing. And it says -6AN, which should relate to 3/8, but it's not quite 3/8. It's actually a hair under. And I'm going to try and do this holding the phone, which I know I keep saying I'm not a fan of it, but here I am. If I use the tool to open the tubing back up, you know, it fits up inside to spread the inner sleeve over if it gets pinched down, which occasionally it will. So this is a great tool to have, by the way. It fits in there, and it'll help spread it back open and make the tube round again after it gets collapsed on the end. And it's not a terribly snug fit, so it's probably a couple of thousandths over that. And if you mic this, or I just quickly use a caliper, and this is an accurate caliper. I've been using this for a while, and it's well calibrated. If you hang a caliper on it or a mic, you'll see that it's about 320 and change. Or what do I get on it? A 315. So we got a couple of thousandths, a little bit of play in the sleeve on top of that. So let's say we got about 320 in diameter in the actual hose ID. And 5/16 would be 312 and a half, and 3/8 is 375. So it's definitely under 3/8. It's somewhere around like 21/64, something like that, which is enough for this motor. I'm only max, you know, this is normally aspirated 5.3, so you know, I'm expecting somewhere around 400 horse, maybe 4 1/4, something like that. But you know, that should be more than enough diameter to push enough fuel to run that amount of horsepower output. And plus, I'm not going to be spending extended periods of time at 7,000 RPM, anything like that. So we that should be enough diameter. Decide to go with do a set of bigger heads, or a power adder, a turbo supercharger, something like that, and start making a lot more motor. Then I'd have to upgrade to 8AN. But at this power level, this performance level, 6AN should be just fine. And all the fittings and everything are readily available, and it just was it was more convenient to just run in 6AN, and the car performs just fine with that. I don't have any kind of pressure drop at high RPM, high demand through the fuel supply. But and then if you look at the fuel filters that we're using, like a C5 style filter with a regulator, that's all 6AN. That's all 5/16 fittings, and it's listed at 3/8, I think, on the supply side. But if you actually, I think if you mic it on the inside, you'll see that it's actually a little less than 3/8 anyway. So we're fine there. So what I'm gonna do is I'm gonna pull the CPE 6AN line out and run the 6AN PTFE, and there's my supply line running out. So I've just got to break that fitting, and what I'm probably going to do is attach the new line to the old line. I don't know, try and snake it through like electrical. I don't know. I may just drop it out. I got to get under the car and see how packed in it is. It may be easier to just pull the old CPE line completely out and rerun the PTFE. If I remember, when I routed the CPE line through around the trans-cross member and around some of that, it was a bit of a pain in the butt to get it snaked through. So we'll kind of take that as it comes. But I'm going to get that line disconnected at both ends and start snaking it through and get it updated. And then what I'm going to do next is, like I said, I've got 42-pound LS style injectors in this, and I'm concerned looking at the VE map. I don't think the injector flow rates were correct. And I know, given the length of space, the length of distance between my regulator and my fuel rail, I'm actually getting about 56 psi, 56 and a half. So I need to adjust those injector flow rates down and then retune it, retune the VE table, and go through from there. I've also made some changes to the power enrichment table. What I noticed a little late was that the factory power enrichment didn't come on. It only came on at 95% throttle and higher, and essentially I wasn't getting any power enrichment through the ECM until I was at wide open throttle. I wasn't getting any part throttle power enrichment. I really want to have some of that because of the output on this motor, and the way the cam is going to need a little extra fuel down bottom because it's got a pretty decent overlap and it's not terribly efficient, low RPM. So I adjusted the power enrichment tables down, and I adjusted the flow rates down. I wrote a tune to go through the VE table again and get a retune and see if it smooths out my VE map. Because an issue I had was when I wrote the VE, when I set up the VE map, and I'll show you this in the next video when I get when I get better into the tuning, or more into the tuning again. The table has a real high peak. You know, when I get up a wide open throttle, it's actually when I get down a real low map and real high throttle positions, the VE table was coming up with a cylinder efficiency, a volumetric efficiency of well over 100. I think it was peaking at like 160, 170 at like 5,000 RPM and wide open throttle. And obviously, this motor is not making 160% efficiency. So what that tells me is that that efficiency is based off the ECM calculating the injector flow rate output, the injector output for a given RPM, and then it calculates how efficient that cylinder is, because it knows how big the cylinders are and what the displacement is accurately, but it uses the fuel to determine how efficient the cylinders are at a given point in time, or a given throttle position, engine load and RPM. So it's miscalculating that, and I initially didn't see that as a big deal because essentially their numbers on a chart. As long as the ECM can read it, it'll deliver the correct fuel, and it'll compensate for botched injector flow rates. What I didn't think of ahead of time is that it uses that cylinder efficiency to come up with a proper cylinder air mass number, and that cylinder air mass number is then used by the timing tables to determine the correct timing for a given cylinder air mass. So I'm getting the timing is a bit retarded, and I've been tweaking the timing up, and it performs great, but I think it could be better. I think there's a lot more power left in this motor, and I think the problem is that when I'm at wide open throttle on the timing tables, I'm right at the top of the table. I mean, it looks like I'm running a supercharger. I'm hitting the limit of a 1-bar map sensor. Which, I mean, I can go to a bigger map, but what I need is accurate numbers to start with. So I need to go back in and adjust the injector flow rates down and reset the VA table, and then I'll take a look and see what that does to the cylinder air mass numbers and what that does to the injector the timing tables, and take a look at it from there. And then there's a weird anomaly on the VE table that's I've got a valley and a ridge right around, like, I think if I recall, 1,600 or 2,000 RPM. That I might be able to correct out with by bringing in power enrichment a little earlier and getting a better injector flow rate data in there. So we'll see what happens. That's going to be on the next video, but I'm going to get going pulling this fuel supply line out and rerun it, and it should be a pretty easy job. And I'll touch back at various points to highlight stuff. And I'll talk to you later. All right, so here's my filter regulator at the back. All right, let's see if we can get this thing going. That's actually a little bit of residual fuel out of the line. And actually, I'm not getting anything out of it, so okay. All right, we're good. Now I'm just going to snake this line back out. All right, so there's a fuel line routing coming down past the bell housing and along the side of the trans. I felt a lot better about running it next to the trans and then crossing over here to the frame rail. And then it runs down above the frame rail and goes over the wheel arch and drops down next to the tank. It's sagging a bit now because I have it disconnected over the fuel rail, so it's usually quite a bit higher than that. I wouldn't want it necessarily sitting that close to the exhaust. Because I've gone and it's already disconnected over the rail. So I'm going to snake this line out, get rid of that clamp, or loosen, take the clamp off and get this out. And then I think I'm going to cut the line and tape it off to the new line and use that to pull it through, because it's a bit of a pain in the butt getting it up on top of the frame rail and getting it to feed through the trailing arm mount in the back. See if we can see it in here. And here it comes across the top of the frame. So getting it through that box in the back of the frame and the trailing arm mount was a bit of a hassle last time. So I'm just going to tape them together, and I'll use the old line. As I pull the old line out, it'll pull the new line through. And then, of course, it drops down on the frame rail and goes over to the tank, and that part's easy. But getting it up to here was the challenge last time. So let me nip these couple of zip ties off and get that clamp off, and I'll start pulling this line through. All right, so it's a pretty snug fit between the firewall and the fuel rail, so I don't want to be messing around trying to get the fitting on down there with no room to work. So I'm going to set the 45-degree fitting that goes to the fuel rail up here, and then I can snake the whole line down and attach it, and then use that to set the routing of the hose so it's not hanging down by the trans linkage and all that. I'll open this guy out. And again, these are the PTFE fittings that are a slip over with no threads on the inside like a CPE, because it doesn't grab the outer protective layers of the hose. This should just slip right over. And then we got to make a little room to get the ferrule down there. Get this on camera. Yeah, we're getting that. Just like a Chinese finger trap, this braid is on a diagonal. As you spread it, it'll shrink. So the inner liner should start becoming more and more exposed. And it just tells me that it's opening up. We're kind of pushing this down, and then you'll have the occasional stray fiber, stainless fiber sticking up, or stainless wire, and then you can use your pick or screwdriver to get in there and make sure they're clear, because you don't want to catch one under the ferrule. You can see how it's pushing down now, and the sleeve is exposing. This was a tip from a viewer too, about don't focus so much on digging between it, but push it down and it'll open up, and you can actually see the braid getting wider. Let's see if this will sit down on the... This will go in, and I can see the white PTFE sitting up on the boss. Yeah, get you on camera here. Okay. I don't know how clearly you can see it, but the white PTFE liner is sitting right on the aluminum land. There's an aluminum ridge that runs around the inside here that liner slips up and butts against. So that's doing nice. Once I get this line pulled all the way back by the fuel tank and by the fuel filter, then I can cut it to length down there and put the other fitting on, which I think will be a straight. But I have a lot more room to work back there than I did up here. If I was trying to get the fitting on here and clear the line, get the ferrule on, it's just too much room for mistakes. So now, essentially, I can feed this guy right back down. I'm hitting the shift linkage, I think. I'm going to get underneath and start drawing it in. And once I get the line clear, I can get my hands on it, then I can pull this thing all the way through. I just want to make sure that the 45 I just put on isn't wrapping off the fenders and getting hooked on anything on the way over, because it's going to have to draw all the way up the fender. All right, had to take a break and feed the sandhill cranes that are here, as usual, for breakfast. Let's see if we can start drawing this hose down. That's the sound of an old guy getting down on the ground. God, I wish I had a lift in this shop, this garage. Soon. Let's see how far we are. A little bit more. That should be it. I'm close enough to get the fitting on anyway, so I don't over pull it. Yeah. These are swivel fittings too, which makes life a lot easier. The line wants to lay a certain way, you can spin the fitting around and still get a clean shot, a clear shot. I don't know if you can see, but the the waterfall of sweat has officially started. My brother keeps telling me I should wear a headband. Not a bad idea. This time of year when the humidity's up, man, it is maddening. I'm trying to bias this fitting a little bit because it wants to, as you're tightening it, it wants to spin the fitting. Wants to spin the inner, so it's swinging the angle way out. So I'm going to start with it way over here, and then as I tighten it, it'll bring it back straight. And that should be good. Once I get this thing reconnected, I can pressurize it, make sure I don't have any leaks. Hose isn't binding on anything. I wish it was a little straighter up and down because I'm just weird like that. I'm going to do is see if I can't. Oh, it's a 3/4. Get a little more pressure to keep this line straighter. These AN fittings don't need a whole lot of torque. And what's the nice thing about what makes them work so well is the aluminum is pretty deformable. So it'll make a good seal without a whole lot of torque on it. So it may look like I'm really cranking on it, but I'm not. I'm just going back and forth to make sure the tapered seat is seated and conformed and trying to get the fitting straight. Because if you're going to do it, it might as well look good. And again, I think that's fine for now. I'm going to, once I get it pressurized, once I get the line in, I can pressurize it, make sure I don't have any leaks, and give it a final tweak if I feel like I need to. Now let's get the bottom run and pulled to the right tension so that line's not hanging anywhere dangerous, and we'll go from there. All right, so here we are. Cut to length. Just gonna get this dopey tape off the end. Oh, need to drop oil on the threads. We're almost there. There we go. Before I tighten that down, I'm just going to make sure this is routed good. All right, well, wish I could get a little further away, but the ground only allows me so much room to back the camera off. But I'll tuck it up tight next to the frame there, between the frame and the tank, and then I'm going to use a band clamp, or a P-clamp rather, to hold it to this cross member. And the angle's a little deceiving, but we got a good, like 8 inches between the exhaust tip and where that line's going to run. The line's going to run right along where you see the exhaust hanger bolted on. I'm going to put a P-clamp right in that threaded hole. And that's pretty much it. And then we'll turn the pump on, let it pressurize up, and make sure we don't have any leaks, and we're good to go. All right. Hey, feel free to comment if you have any ideas or thoughts, and please like and subscribe. And I'll try and keep the stuff coming. I hope you got something out of it. Have a great day. Bye-bye.